Okay. So today we'll see, I continue with the again a few of the slides, maybe today morning. So I little hurriedly, gone through, but again I'll repeat a little bit. Okay. So once the DFT is ready as part of your structured analysis, right? So now as part of your structured design, we try to transform this DFD model into structure chart, right? So so usually, we go with two different strategies. So, in order to transform a DFD into a structure chart. So the first one is transform analysis and the second one is transaction analysis. Okay. Now, the first step here is what you try to do as part of transform analysis. So whatever the DFD that you are getting, that you will be dividing into three different types of parts. Okay, so one part will be input, the second part is logical processing, and the third one is output. Okay, so like what are the different processings that will be going into input part? Some of the processing will be going into logical processing, and some of them will be going to output. Okay, so this way whatever the all processings that we are the functions that we identified as part of DFDs will be divided. Okay, that is what we try to do as part of transform analysis. Anyway, we will go through an example also, if you can understand later on if you do not understand, right? So here what you do is, so as part of your input portion, what do? You try to identify the processings or the processes which actually convert your input data. Okay, that may be in the form of physical form, I mean, like the whatever the input actually data that you will be taking from the user. Okay, so that will be converted into a logical form. That means, for example, here you can see, so you read the characters from the computer terminal, maybe from the keyboard. Okay, maybe A, B, C, 1, 2, 3, 4, all those things, and then you will be storing that in your internal tables or the list or the data structures. Okay, so that means you do the transformation, right? You try to convert them, right, physical to logical. So now this sort of portion, these sort of processings are called as afferent branch. Okay, so sometimes you have many afferent branches because you have many inputs, such sort of physical inputs. Okay, for a particular input system. Similarly, output portion. So usually there are the processings which will actually convert that output data from a logical form to the physical form. Okay, that means maybe the data stored in the list. Okay, that need to be shown to the user. So what you do, you try to convert that into a physical form which can the user understand. Maybe again in the form of characters. Okay. So that is what we call as afferent branch. Okay, the remaining portions, that means the remaining processings or the functions, the processes, so they will be part of central transform. Actually, they are doing some logical processing. Okay, so usually you have to so like you have to get this data structure. I mean, you get this structure chart. By drawing all of these, functional components for these different, uh, you know, transforms, right? So maybe you have, central transform, you have afferent branch, and you have afferent branch. Okay. So usually, to do this, so usually you first going through high level input and output transforms. You will have to identify them. Okay. And you can see, so what I mean, you need to get those processings, right? So I mean, which cannot give you the output just based upon the only single input. So it's not like that. Okay, so you will have to identify all of the inputs. Okay. So I mean, so as to get some processings, right? So which really need some input, and based upon which it is going to process, okay, something. So some processing is really required, right? So now there are some of these processes, as I told you, right? so which really do processing in order to say that whether a input is a valid or not. So this is also a kind of processing, but they are not the part of central transforms. Okay, so usually they are so just a validating sort of processes. Okay, so I mean usually processes which do some logical processing, right? Maybe sorting of some inputs. Okay, that means you really require a sorting algorithm there to sort certain number of input data. That means so based upon this input, so usually some output will come, right? So this is what exactly uh, okay. Uh, Now, so here what you try to do, so you will be getting the first level of structure chart. So simply, so whatever inputs and outputs units that you will identify, for them you draw a box, okay, and a box for central transformation. I'll going through an example, then you will understand how we are going to make a box there, right? So and then what you try to do is within that particular box, right, you try to identify each and every sub functions required, okay, and that is the way that and then you will be identify sub functions of those sub functions, right? So as a result you will be getting many levels of the modules, okay. So right. So usually, as I told you, so that there is a very important concept of factoring. So the factoring is nothing but it's a process of breaking the functional components as a subcomponents, right? So maybe it is something like this, right? So you will be dividing, some of these modules which really involves in reading and writing, right? Those can be called as read and write modules, okay? Some modules are capable of handling error, right? So those modules are error handling modules, and some of these modules, they do carry out some initialization and termination, this sort of. So this is the way that you will be, um, you know, you breaking, the functional components into subcomponents. Okay. So finally, so then you need to see whether all of these bubbles have been, whatever the bubbles that you have seen, so whether all of these bubbles are mapped to particular modules or not. Okay, so that means you can think of something like this. Okay, there is a read write module bubble. So so those bubbles, whether that is going into read write modules or not. Okay, if there is a bubble which can do some error handling things, right? Whether that sort of functions, related functions, or the processings or the bubbles that will be going into that particular module, okay, error handling module, okay. And that is the way that you will be going to finally check whether all of these processings or the functions, so whether they are mapped to a particular module or not. Now we will see, and we'll try to convert a DFD into a structure chart. How we'll see through an example how we can do this through an example. So here is a root mean square calculating software. That is what we have seen. We have taken this as an example to draw our DFDs, right? The same thing we are taking here. So we have the context diagram here, right? So user is going to input some data items, and then it computes root mean square of the input items, okay, and it is going to give that root mean square value as a result to the user, right? Now, so then so usually, so these are the various requirements that need to be met, okay, as part of your RMS calculating software. We have seen in the previous lecture also, right? So accept the input numbers from the user, so it is going to take three different input numbers or four input numbers, right? And then we need to validate those numbers, right? and then finally we calculate the, after the numbers are validated, now those numbers will be given as an input to the root mean square. Okay, and then the root mean square module will calculate the value, and then the result will be displayed, right? This is what we have seen, right? So now for this, the level 1 DFD is something like this. Okay, so then what you try to do is you just you can see here something like this. Okay, so I told you there are efferent, and then you have central transform. So there are three sort of bubbles. Okay, so now whole, the number of bubbles will be divided into these three categories, right? Now I told you, so read numbers, that is all belonging to efferent one. Okay, because I told you, right, that is all doing something, reading, I mean some data items from the external entity and transform that into a logical form, right? And also I told you there are some processings which do just validate, validating a number, right? That means usually it is not a central transform, right? This is not the central processing or the function, right? It is just a processing which it is exactly just doing checking whether a number is valid or not valid, right? So now these sort of processing is also part of afferent branch, right? That is the reason why these are all circled. I have made something like and now there is a display processing. That means it is all about afferent one. Okay, so it is all leading, the input, some of the input, whatever it is coming, that is to be displayed. Okay, that is displayed or that is given as a result. So that means here this is the processing actually going to transform the logical data into a physical form, right? Then only the external entity or the objects or the users can understand this data, right? So now these sort of processings are called as afferent one. And now the compute RMS, so this is actually the central transform. So this is the way that you will be identifying, you will be categorizing these three types of processes, right? Is it clear so far, students? Is that, is it clear?
Yes, sir. Yes.
Okay.
Yes, sir.
Okay. So that is what exactly we do. So there are afferent branch and afferent branch, that is what we identified, and the final one is a central transform, right? So now then what you do? So I told you, right? So first you start with a root, okay, and thereafter I told you, so make one box, okay, one box for the afferent, one box for the central, and one box for the afferent, okay. So that is what you are going to get, three different boxes, okay, for this. And then what you are giving, so now this particular module, the module, now for once, this module can also be divided into sub functions. The sub functions is, so get the data, okay, and then the second sub module is, or the sub component is, validate the data, okay, whatever. So that means one processing, so which is going to get the data, and the other one is going to validate this, okay. So now these are the two sub functions. That is, this is the way that you go on dividing your modules, okay. This is the level of abstraction that you can maintain, right? This is the way. Now what is happening, so this get data module is actually going to get the data from the user, okay. And then whatever the data is given to the get good data module, now get good data module actually simply sends back to the validate data processing. Now the validate data processing is going to handle this, okay, whatever the data it is going to give, so it will be simply validate, and the validated numbers actually will be given to the root module, okay. Now root module, what do you do, because it is a valid number, now root will root module will send that particular valid number data again to the compute solution. Okay, that means compute RMS. Okay, module. Now again further you can divide this compute solution into sub modules. That is up to you. Okay, the way that we have seen. Okay, but you need to identify that whether these processings are actually doing similar sort of activities or not. So all similar sort of activities will be actually part of a particular module. Let's say I told you, right? So error handling modules. Okay, so those modules are actually going to handle. I mean, the processings will be mostly handling the error handling related. Okay, if at all any error is appearing, so in that case you will be going to how this the software is going to handle by using those processings, right? So similarly, once the data in a valid number is given to the compute solution, then the compute solution is giving back the result to the root, and then now root module is sending back to the display solution. Okay, so that means this RMS value is given to the display module, right? So this is the way that actually so a structure chart can be created. Okay. So from your DFD, we actually converted that into the structure chart using some guidelines. Okay, so it is up to you. So we first discussed structural analysis of larger problem. We defined some general guidelines, right? So first you have got a DFD, right? So and also we have seen uh, DFD is a very simplest one and it is very much useful, but still we have seen certain number of shortcomings. Okay, so then we started discussing about the structure chart. Okay, I mean structure design part, how we going to transform this DFD representation into structure chart, right? And finally, your structure chart represents the module structure, right? What are the different modules and their interactions, right? And but the procedural aspects, right? So that means the internal details of the procedures of the functions. So they are not represented at this point of time. Okay, using a structure chart. That's are not, they are not part of structure chart. Okay. So and also we have seen transform analysis and transaction analysis, right? So then you have taken a example of this structured design, right? So it's a right. So you need to understand and then you need to develop any good software. You can develop good software design, you can design a very good software, right? So if you can understand all of these things, right? So these are the important practices one can use, okay, to design your software, right? So any doubts of our students about this structure design and all? Is it fine?
Yes, sir.
Okay. So I switch into the other topic. Okay. So just let me upload the topic slide. Okay, so far we have discussed about the function-oriented software design. Okay, so from now onwards we will talk about the object-oriented software design. Okay, so I told you these are the two different approaches right? um, so we have discussed about the function oriented, right? So in this lecture we'll talk about various object oriented, we'll discuss about various object oriented concepts, and then how we can do object modeling using some unified modeling language. Okay, and then maybe we'll talk about next to next lecture about object oriented software development and some patterns, software design patterns, right? So now then, so these these object oriented design techniques, they are becoming very popular day by day. Okay, still since it is starting from 1980s. Okay, so today mostly in many software developments, right, we try to use these all different object oriented design techniques, right? So mostly in many industries, so people are using this object oriented design techniques, since because there is a very good growth in the object oriented programming languages, right? Also, so unified modeling language poised to become a standard for modeling object oriented standards. So today we have a UML, right, unified modeling language, so which is also a standard for modeling object oriented systems. Okay, so we'll talk about this UML a little bit more, but before that we'll talk about the object oriented concepts, right? So because of these concepts only, so now this object oriented programming language and is very much popular, right? And it is in the currently it is being widely used in the industry, right? So what is an object actually? It's a very real world entity, right? So something that exists in the real world, right? So a system is designed as a set of interacting objects. Now when you say object oriented system, so usually so you can think of like so it comprises of certain number of objects, and these objects are interacting, these objects are interacting, these objects are interacting, and through their interactions, so they try to establish or accomplish a particular task. Okay, so consists of data and functions. So you know so usually a object consists of data as well as some methods. Okay, so attributes as well as some methods. Okay, those you have these methods that exactly operate on those attributes, right? So hides organization of internal information, right? So it also maintains a data abstraction, right? So due to through the mechanism of encapsulation and all, so whereby you can see so objects actually they hide internal information, right? So now some examples of object is an employee, a book. So these can be considered as objects, okay, because they really exist in the real time. Now you can understand, right? So there is an object, okay, and within that particular object, so it contains data, right? And now certain number of methods. So you can see M1 to M8. These are the methods they're trying to operate on that particular data. Okay. So this is what the central concept of an object, right? Now, what is a class again? So class is the instances, they are the instances. Okay. So, I mean, so, so, so you understand something like the wrapping up of, data and methods into a very single unit. Okay. So that is what we call as a class, right? So now you will have certain number of instances for that particular class, and those instances are called as objects. Okay, so right. So now as you can see, best example can be like this. Okay, so color. If I say color, so color can be a class. Okay, now maybe as part of these colors, so let's say if I say green, blue, yellow, so these are the different instances of that particular class. Okay, color. So now yellow is a object of that particular class color. Okay, so this way, right? So usually class is a template for object creation. Okay, so it is a template, right? And some classes are also abstract. Okay, there are also abstract classes. So they are not going to provide any instances, rather they are being going to they are being abstract to other classes, right? So and we can see so there are abstract data types also, right? So they can be also examples of class we have already talked about, like stack, queue, and they can be some of the abstract data types, right? So there are also the classes, right? And uh, now, so a example of this class, and let's say if we can say employee is one class, so now a set of all employees may be the objects, okay, of that particular class or the instances of that particular class. So if book is a class, then different types of books, they can be the objects of a class book. Okay, this is the way that you can understand. Any doubts so far, students?
No, sir.
No,
Okay.
sir.
Okay. Now, as I said, your objects. So they comprises of data attributes and methods. Okay. So usually when you say method, so there are the operations. Okay, they are the operations supported by an object. Okay, so that means these are the various actions by a particular object. Okay, so let's say if you say dog, okay, if you say one of the object maybe dog, okay, so not dog can be a class. Okay, maybe if you say part of in a dog class, you can have different types of dogs. Okay, so you know that. Okay, there are different types of dogs available in the world, right? So can anyone tell me one type of dog?
German Shepherd.
Yeah, right. So this is the way that you can understand, right? So right, as I said, so now, but each and every dog have certain number of actions or the operations, right? Operation means maybe barking, barking one of the operation. Okay, so they continuously do eating. Okay, so these are the various operations, right? So and these operations, they actually going to manipulate your data. Okay, and now these operations, can be invoked by sending some messages, right? So now one object can call the methods or the operations of another object by sending some messages. That is what message passing. Okay. So maybe you can have something like this: calculate salary, issue a book, member details. So these are the many operations, right? So and these operations can talk to each other by message sending. So and there is a very important concept called inheritance. Okay, so now there is some concept of something like this. Okay, so you have some base classes. Okay, so and now there are some derived classes. That means the derived classes are the ones who are going to inherit certain operations or the properties from its base class. Okay, that is what we call as inheritance. Okay, so that means you can think of something like this. So the children so they are going to inherit certain properties from their parents. Okay, so this is the way that represents generalization specialization relationship. Okay, so usually we will see there is a concept of generalization, that is what so we try to generalize certain things, right? And we'll talk about this generalization and specialization. Okay, so allows redefinition of existing methods and method overriding. So it also, there is a concept of method overriding, right? So you try to, you know, what you say, uh, something, uh, you know, so if something is there, you try to replace that, or sorry, not replace. So you try to modify something, right? So let's say, for example, it is something like this. Okay, so you have a method in its base class, and so as part of uh, you can say something like this. Your derived class will also have a method, right? So similar sort of method, but now you wanted to have something little modified as compared to the method that you have in the base class. Okay, so that is also allowed, yeah, because of inheritance. Okay, so that is what we call as method overriding, right? So there is a method overloading also, there is a concept. Okay, so that means as part of your method, so so as part of a particular class, maybe it is a derived class or maybe it is a base class, as part of that particular class, so you can have you know two similar methods, but varying in different maybe they so same sort of method, but they will have different forms. Okay, right? So maybe something like this. Okay, so summation. Okay, some let's say sum of sum is a method, right? Now you can see, you can have something like this: summation of two numbers, summation of three numbers. There is a method for summation of the four numbers. Okay, so now all of these methods will have the same name. Okay, they have the same name, but their characteristics is little different from each other, right? So one sum method, so it is going to do carry only summation of two numbers. The other sum method is going to sum three different numbers. The third sum method is going to do summation, going to give you the summation of four numbers, right? So that means, so the same method, but they are in the different forms. Okay. So that is what we call as sometimes polymorphism, right? So that is also available, right? So method overriding is something, so you have some method, okay, in the base class, and you have a similar sort of method in the derived class, but this particular method is maybe you wanted to redefine. Okay, or maybe it is quite little different from the method that is there in the base class. Okay, so this is the way that method overriding works. Okay, so one best example can be constructor overriding. Okay, you can understand now. Right. So there is another concept called multiple inheritance. In that case, what will happen? So in this case, what will happen? You have a subclass or you have a derived class. Okay. Now this derived class is going to inherit the attributes or methods from more than one base class. Okay. It is going to derive or it is going to inherit attributes and methods from more than one base class. Okay, so that is what we call as multiple inheritance. Okay, that means you have multiple parents. Okay, so a children who is going to inherit certain properties from multiple parents. Okay, so something like that. Okay, so multiple inheritance is represented by arrows drawn from subclass to each of the base classes. Okay, we'll see through this example and you will be able to understand, right? Now you can see here. Okay, so the left side diagram, So it also, let's say there is a library member, okay, is a base class. Now, so faculty can be a library member, student can be a library member, staff can be a library member, right? So your base class is library member, and these are the derived classes. Okay. Now further, undergrad, graduate as well as research. So there can be you can have different other derived classes to the student class. Okay, because undergraduate student there is a postgraduate student and there is a research student. Okay, so this way you can have, right? So the arrows these are the way that um, you can represent your derived classes and base classes. This is what we call as inheritance. Now here in the right side you can see, now there is a research student who is a who is a research student as well as he is a research staff also. Okay, so there is a person, okay, or a research personnel, okay, who is a student. I mean, he may be doing maybe, let's say you can think of there is an employee, employee is a part of a particular you know employee who is part of maybe the institute, right? In our NIT or Kerala, maybe you can think of like, so there are technical staffs, right? So technical assistants, right? So now they are the staff, and they also, if they are pursuing PhD from this particular department, so in that case what will happen? So now they are going to inherit certain properties from staff as well as certain properties from the students. So now this is what we call as multiple inheritance. That means this research derived class is going to inherit certain properties from the parent class staff as well as the parent class students, right? So this is what we call as multiple inheritance, right? So another important concept is part of object-oriented uh, concepts are abstraction. Okay, so consider aspects relevant for certain purpose. Okay, so this is these are the very important attributes. Okay, so that is sometime it is really required in any object oriented systems, right? So suppress non-relevant aspects. That means, so something which is not very much relevant. Okay, so you can have, and something which is required you can have, and something which is not required you can suppress them, right? So this is the way that it all works, right? Supported at two levels: class level, where base class is an abstraction. Okay, so you can understand, right? So your base class will be can be abstract. Okay, and the object level, where object is a data abstraction entity, right? So you can understand, right? So there are two levels of abstraction, right? One is at the class level, the other one is at the object level. Okay, so in the class level, so your base class is an abstraction, right? In case of object level, where object is the data abstraction itself, because so the data uh, you can understand by seeing its object. The data is completely abstracted, right? So now the advantages of this abstraction is it exactly reduces complexity of a software, right? So that means, and increases software productivity, right? So usually by using because ultimately, so we have seen abstraction is something which is exactly trying to reduce the complexity of the software, right? Which enhances the understandability of the software, right? We can easily understand the complexity of a problem through different level of abstractions, right? That is what we have seen in case of um, uh, modularity, right? In software design, right? So it is shown that the software productivity is inversely proportional to software complexity, right? So usually, um, if the software is very complex one, in that case, the productivity will be very less. Okay. So in order to get this, in order to come out from, if you want to have, if you want to get a better productivity, in that case, definitely you need to go with some sort of aspects which really will reduce the, which will increase the software productivity. That is what we call as abstraction. Okay. So the other concept here is objects communicate outside world through messages. That is what we have seen, right? Objects data encapsulated within its methods, right? So you can understand, right? So your data and methods, they are actually encapsulated. And if anything, if anything needs to be given to the outside world, that will be done through the message passing, right? So you have the data and you have the methods. That is what the concept of encapsulation, right? These are the methods going to, access the data available within a particular object, right? So and there is a concept called polymorphism, right? Something that comes in different forms. Okay, so you can understand now you have the same method, but it will have different forms, right? As I told you, so you have methods with different signatures, right? Some messages result in different actions by different objects. Okay, so now you can understand. So now you can think of this is a very example of a static binding or the method overloading. Now you can see, so there is a method called create. So this particular create method doesn't take any arguments. Now the second create method is going to take three different arguments. Now the third function method create, that is going to take four attributes, right? Now this is the way that you can distinguish one operation or method from the other, right? So the first one is going to create an instance of it is going to create a instance of a circle, right? Now in the second one, so it creates a circle with maybe with XY coordinates, right? As well as also it is going to take the center. Okay. So and also in the fourth one, a third method, so it takes XY float center, so it is going to take the center as well as type. Okay, so what type, field type that you want, okay, for a particular circle, right? So at the compile time, any of these particular methods by creating an instance of this particular class circle, right? So this is what we call a static binding, right? So a class named circle has three definitions for create operation. That is what we have seen. One is a without any parameter, that is a default one, and the other one is a center and radius. They are going to take as a parameters, right? Now there is something, there is a concept called dynamic binding. So what we have seen is a static binding. So during compile time, you going to call a particular method by sending messages, right? So you creating an instance of that particular class, and then by passing the kind of message, okay, suitable to call that particular method, so you actually going to call that particular method, right? So let's say you calling that create method without passing any parameters. In that case, the first method will be created. That means without without parameters. Okay, that's if you passing, let's say, three parameters, so then in that case, so the second will be called. If you passing four parameters, then in that case it is going to call the third method. So this is the way that you actually create the static binding, right? But in case of dynamic binding, so right, so what you do is during, because I told you, so here you have a inheritance, right? So that means you have a method overriding concept is there, right? Yes, because there is a method overriding concept, so at the runtime it will be decided whether what sort of method you are calling, whether you are calling the method of base class or you calling the method of it's a derived class. So that will be decided at the runtime. Okay, so that is what we call as dynamic binding, right? So exact method cannot be known at the compile time. That is not known at the compile time. It will be decided at the runtime. That is what we say. Okay, dynamic binding. Right. Now there is an example you can go through and you can understand this example. It's a maybe you can create a class of you can create a class of safe and under different shapes as a derived classes, and then you try to override certain things and then you call. Okay, so this is what exactly, so you have a shape class and under this you have a different types of shapes, right? So part of circle you can have an ellipse, again part of rectangle you can have a square, cube, and like this. So right, you can create the hierarchy of different classes. That is what we call as inheritance. Now, so what's the main advantages of I mean, you can see, right? So you have a traditional code where you can have this sort of thing, right? If your shape matches with the circle, then you draw the circle. If the shape matches with the rectangle, then you draw the rectangle, right? Now here, what you are doing here, you are just when in case of object oriented, what you try to do is you just calling a method, you know draw method, which is a part of this shape, right? So and then based upon the based upon the parameters, now you will be able to dynamically you bind a particular method, okay, or you call a particular method, right? So this is what the advantages, right? Now you can see there are four number of lines of code to call different shapes, but here in this case you really need only one lines of code, right? This is the way that you can see code reuse and all. Okay, so advantages of dynamic binding. So it improves the code reuse as well as it will be helpful in the maintenance. Okay. So whenever you wanted to add any of the new objects, so in that case with very minimal changes to the existing objects, now you can create, that means you can add the objects as many as whenever you required. Okay, but if you are going through any traditional approach, what will happen in that case, you will have to make many changes when you going to you know uh, add some of the functionalities, right? But in this case it is very much easier, right? So there are concepts called composite objects, that means where certain objects containing other objects, right? So and also you can have some sort of hierarchy, tree hierarchy, where the composition is, you can have, again you can the for one object can be contained on the other object, and that particular object may be contained in another object. So in this way you can have a tree hierarchy also, right? So right, so you should not be confused between this, inheritance hierarchy, that is what we have seen, right? Class inheritance and your, containment, object containment hierarchy. So these are little different, okay? So as part of any composite object, so you will have something like two different object types, will have similar sort of features. Okay. So whenever you do have various number of objects involved, in that case, you can show this containment graph, okay, or you can draw this tree, so where you can show that I mean a particular object is created by adding certain number of other objects. Okay, this is what exactly a containment tree is all about. Okay. So there is a concept called generosity. Okay, so it is very much equivalent to template class in C++, as well as what you say, generic class in generic concept in uh, Java programming language. Okay, so where you will be able to parameterize a particular class also, right? So class stack of different types of elements such as integer, character, floating point, stack, this sort of, right? So now you create a stack. Okay, today maybe that stack will create a stack of integers. Tomorrow same stack can can be used to hold a set of characters. Similarly, the day after tomorrow it may be going to take floating point numbers. Okay, so is the elements of that particular stack, right? So now that means once you created a stack with a parameterized um, if you parameterize that particular class definition, in that case you will be able to reuse that particular class. Okay, so generosity permits to define generic class stack, later instantiate as required, right? So this is the way that you will be going to use these general generic classes. So what are the advantages of this object oriented design? So the first advantages here is code and design reuse. Okay, it exactly helps you in increasing the productivity. So it will help you in easing the testing activity as well as maintenance, and it increases the understandability. Okay, so it also, as I told you also, it actually going to increase the productivity. So this is one of the very important advantages of this object oriented design. Now the other advantages here is maybe initially when you are going through any this sort of object oriented design approach, maybe it incurs higher costs, but once when you are going or nearing towards the completion of the projects, so you will see the cost of projects is actually reducing. Okay, right, well-established object-oriented methodology and environment can be managed with 20 to 50% of traditional cost of development. Okay, now what we say is, so that means the cost because of this object-oriented methodology, so it increases up to 50%. It it actually decreases the cost by 20 to 50% as compared to the traditional cost of development. Okay, so that's the reason why nowadays the industries are actually moving towards this object oriented design. So there is a concept called object modeling, right? Anyway, we'll stop here at this point of time. Maybe in the next lecture we'll talk about this object modeling, right? So, so any doubts of our students using related to object oriented concepts?
No, sir.
Okay, right.